guys, now that we've reviewed some terms, how to read that mini tab out, but let's actually go and say, hey, we know, you guys know this slope right here, this is not our true slope. This comes from our sample, okay? This comes from our sample, and it was a sample of 16 healthy young adults. Now what I want to do is I want to go ahead and I want to construct an interval for the true slope, okay? Again, this is just a statistic, just like we have an X bar or a P hat. Now this B value right here, our slope, that is a statistic as well. Can we find a lower bound and an upper bound that contains the true slope for the population? That's our goal right now in this video. So we go ahead with the state, plan, do, conclude model again. In an interval, all we want to do is state that parameter that we're looking for. The true slope is not mu, it's not p, it's called beta, and this is the symbol. Beta equals the true slope relating any change to fat gain. Again, state, plan, do, conclude. State is the same all around. For intervals, state that parameter that you are looking for. Next, the do. The do is where next is the plan. Forgive me, you guys. The plan is where we state our conditions. Before, we've been dealing with RIN, okay? It does change quite a bit when we're dealing with regression, okay? The plan is, our acronym now is not RIN, it's liner, okay? Liner, think I have a regression line, liner, to remember that. And then we also have to say what our method is. For a liner, the first thing that we need to do is we need to show that our data is linear, and we also have to check the residual plot to make sure that it is appropriate, okay? So let's do that now. What's nice, ladies and gentlemen, is if you look, they gave us the regression plot already here. So we know that this plot right here is linear. So the first thing I'm going to do, sorry guys, is I'm going to say for my L for the plan, let's type. I'm going to say graph of scatter plot is linear, okay? And let's look at the residual plot. Remember, the residual plot, what we want is we want there to be no pattern. So let's check that now. What I went ahead, and you're going to want to do this right now. In your calculator, you're going to want to put the any change right here and here in L1 and the fat gain in L2. So I'll show you my calculator, stat, edit. L1, I have all of the EA change. L2, I have the fat gain. Pause your video right now and go ahead, and I'll put that there in case you don't have the printed notes out. Go ahead and type that into your calculator right now. Okay, next, what we want to do, ladies and gentlemen, we already know that the graph of the scatter plot is linear. We want to check the residual plot. In order to check a residual plot, you guys, and typically on the AP test, I suspect they will give you the residual plot, but we must be prepared for anything, so you need to know how to put it in your calculator. So in L1 and L2, before we can check a residual plot, what we need to do is we need to run regression. Write that down if you don't think you'll remember. Before we check a residual plot, we have to run regression. How do I do that? I'm going to hit stat. I'm going to arrow over to calc. I'm going to go down. You know what, to be honest, guys, I want to be in my home screen first. Forgive me on that. Go to your home screen. Second mode, quit, will get you to your home screen. I'm going to go to stat now. I'm going to go to calc. I'm going to go to number 8. That's the one we use in AP Stats. I'm going to have L1 as my X list and L2 as my Y list. Now, if you have the old calculator, you just see linreg A plus BX. You can go ahead and hit enter because that's the automatic default, as they will do L1 and L2 for you. We don't need to worry about storing the regression equation. We can just go ahead and we can hit calculate. Okay, we've run regression. We can see our slope here. We can see our y-intercepts here. So first is our y-intercept, then is our slope. We have our r squared, and we also have our r, okay? Next, what I want to do is I want to look at that residual plot. To do that, I hit second y equals. Do that now. I'm going to hit enter on plot 1. My scatter plot is right here. In my X list, I should see L1. In my Y list, I want residual. How do I get there? I want to hit second stat. Again, how do I get here? Second stat. I see my resid is number 8. Yours might be a little different. And now I'm ready to hit zoom 9, which is zoom stat. You can see here there is no pattern in my residual plot, which means the least squares regression line is appropriate to use for regression. What do I need to put in my conditions though? Oops, sorry guys, that's the next lesson. All I need to put, graph of scatter plot is linear, residual plot has no pattern. Okay, L, linear, show the scatter plot is linear, and the residual plot has no pattern. Next is I, in the independence category. We want to put that the responses are independent of each other, or observations are independent of each other. And because this was a simple random sample, I believe, or a random sample of 16 healthy people, we also need to do that 10% rule, okay? So I'll do that below. 10 times 16 is less than all adults, healthy adults. Next, we have N. What does N stand for? N is the normal condition. Now, this is different than what we're used to. What we want to do is we want to look at a plot of the residuals, either with a histogram or a probability plot. I actually prefer for this plot of the residuals, so plot, not the residuals, it's different. It's the plot of the residuals, and it's either with so it's just the residual values as one variable. It's not against anything else. You're not looking at two variables like you do with the residual plot. I'm looking at a plot of the residuals either through a histogram or a probability plot. I prefer the probability plot for this one, so I'm going to show you that one. And what I want here is I want it to be straight or straight enough. Okay? Again, this is all new to you guys. We've already run regression. That's what we need to do when we're working with our residual in our calculator. I'm going to hit second, y equals, and again, on the AP test, I suspect they will give you all this, and you just have to state the plot of the residual, or of the probability plot is straight, okay? The residual plot has no pattern, or the residual plot given has no pattern. And I'll try to find a release exam to show you as well, just to make you feel better. But again, you can never be too prepared, so let's go ahead and make sure we can do this on our calculator. I want to go to the probability plot. Again, I'm not looking at two variables like I do on the scatter plot. I'm only looking at the residuals. In my data list, I don't want L1, I want the residuals. So I'm going to hit second, stat, and I go to resid. Now I'm going to go ahead and I'm going to hit zoom 9 to look at that graph of that probability plot. And you can notice that is pretty straight. So we're going to go ahead and we're going to say graph, probability plot is straight. To sketch that, okay? We do need to sketch that. Let's see, did it go into the negative values as well? I can't remember. Yeah, let's pull it over so we can see it. I'm going to just go ahead and erase that. Sorry, guys. Okay. Again, we're okay to proceed now with that N. Our normal condition has sufficed. Now, E, what does E stand for? Equal variance. We want to look at the residual plots. So equal variance is, it seems a little redundant, to be honest, because we've already checked the residual plot. All we really have to say is that the residual plot shows spread everywhere. Okay, so let's type that here. Which again is really just saying that there's no pattern. It seems redundant to me, but we do need to put it, and I actually just paused to double check the AP rubric you can see here to make sure that, hey, do I really have to be checking that residual plot twice, or do I have to talk about it twice? And you do, okay? Okay, so we're going to just say for E, residual plot shows consistent spread everywhere. What do I mean by that, guys? If I would look at that residual plot, let's go ahead and look at it again. So I would go to second y equals. I'm going to hit enter on plot 1. I want to look at the residual plot. So that's back to the scatter plot, not the probability plot of the residuals. In my X list, I want L1. And in my Y list, I want the residual plot. I'm going to hit zoom 9. And I want to see like equal spread above and below that X-axis there, okay? Consistent spread, so above. So if you would it's almost if you would fold it in half right here on the X-axis, it would match up, if that makes sense. That's what that consistent spread means, okay? Again, if I would fold it in half on the X-axis, so that would be your line of symmetry there, it would match up almost. Again, it doesn't have to be perfect. So hopefully that makes sense to you guys right there, okay? It seems kind of silly, and again, I double-checked it one more time. I've been teaching AP Stats long enough, but I just wanted to double-check for you because I hate when things are redundant. And then finally, R is our random. And what is random about it? Is it a random sample or is it a random treatment? You're just always kind of checking what's random about this problem, okay? And what's random about this problem is we do have a random sample of 16 healthy young adults, okay? 16 healthy young adults. So these conditions are a little bit of a pain. I'm sorry, but now we are ready for the method. And that method is a one sample t-test for beta, okay? One sample t-test for beta. Now let's go ahead, now that we've done our conditions, let's go ahead and let's actually do the fun stuff. The do, oops, I got a little bit moved. Oh dear. There we go. Here's our general form for a confidence interval. Let's go ahead and let's write that down. The do, what is our statistic that we're talking about, ladies and gentlemen? The statistic that we're talking about right now is the slope, and that is B. Plus or minus our critical value. The critical value we will be using is T. T star for degrees of freedom, N minus 2. Okay, N minus 2 times our standard error of the slope. Standard error of that slope. Well, the nice thing about it, ladies and gentlemen, is they give us all of this up in our mini-tab output. So let's go back and look at that mini-tab output. Our slope here is negative 0.0034. Negative 0.0034. Let's leave our T star blank right now. I'll just put a blank. But we do know that our degrees of freedom is 16 minus 2, so that gives us 14, times our standard error of the slope. And again, they tell us that on the mini-tab output. The mini-tab output is right here, 0.0007 is our standard error of that slope, okay? 0.0007. And now we have to go ahead and we have to find that T star using our table. So let's go ahead and let's pull out our table right now with our T distribution. Here is our table. We have 14 degrees of freedom. We are constructing a 90% confidence interval, I believe, but let's double check. Constructing a 90% confidence interval. So let's go ahead and let's find that T star right now. Okay, my degrees of freedom is 14, so we know it's going to be in this row. Oh, I'm on my chi-squared, guys. Double check that you're not on the wrong table. I want to be on table B right now. Okay, table B. 14 degrees of freedom is right here. We want a 90% confidence interval, so it's 1.761. 1.761, because here's our confidence level right there. 1.761. And now what I'm going to do, ladies and gentlemen, is I'm going to just go ahead and I'm going to calculate this by hand. I'm going to take my statistic plus my margin of error and my statistic minus my margin of error. So let's take our calculator out and let's do that now. Let's go to our home screen by hitting second quit. and I'm going to take negative point, the problem when I'm typing on the negative 0.000, I believe. I lied, 0034. First, I'm going to subtract our margin of error, though, so minus 1.761 times 0.0007. You can see that, so I'm taking my statistic, minusing my margin of error. Here's my lower bound, and then I'm going to hit second enter, and that just takes what I just typed in, and I'm going to change that minus to a plus. So now I'm going to add my margin of error. Okay, I'm going to pull my screen over so I don't have to keep going back and forth. So my interval goes from negative 0.0046 to negative 0.0022. And now I'm ready to conclude. I'm 90% confident that the interval from my lower bound to my upper bound captures the true slope of the regression line relating NEA change, that's my X, excuse me, and fat gain, that is my Y, okay? All right, you guys, that is a one sample T interval for beta. Just so you know, you may have to answer a follow-up question like, do you have evidence that there is a relationship between NEA change and fat gain? And that's really getting at the whole question is 0 in the interval. If 0 is contained in this interval, there's a chance that there's no relationship between the two variables. But since 0 is not contained in my 90% confidence interval, again, I always want to say that, we've practiced that before, but because 0 is not contained in that interval, we have evidence that there is actually a negative relationship between NEA change and fat gain. We can go as far as saying we believe that the true slope is between this lower bound and this upper bound. We're 90% confident that that method produced that for us. All right, ladies and gentlemen, hopefully this made sense. If you have any questions, I hope you wrote them down and you can bring them to class. Have a great day.